Assalamualaikum and good day everyone. So today I'm going to show you the difference of concept between iteration and recursion. So we'll be examining two functions that do exactly the same thing, which is calculate the factorial of a number. So the factorial is written as n with exclamation mark, means multiplying all positive integers from 1 up to n. So for example, if factorial 5 equals to 5 times 4 times 3 times 2 times 1, which gives us 120. So here what makes this interesting is because one function uses an iteration, which using a loop to solve the problem, and the other one will use recursion, which will call itself to solve the problem. So let's see how each one works. Okay, so we will start with iterative function, and I'll explain each line one by one. So the first line here, we define a function called factorial iterative, and takes one parameter, which is n. So n is a parameter here, and n represents the number we want to calculate the factorial for. So the next line is result equals to 1. So we create a variable called result and set it to 1. So this will store our running total, and we start at 1 because multiplying by 1 doesn't change the value. So think of this as our starting point. And then for line 3, this is the heart of the iteration because we use for loop. Okay, for looping we can use either for or while loop, but in this case I'm going to use for. Why we write here as range 1n plus 1? If we call this function with n equals to 5, then range will be 1, 6, because 5 plus 1, which will generate the number 1, 2, 3, 4, and 5. The variable I here will take on each of these values and one at a time, and the loop will execute once for each number. And then for line 4, this is where the calculation happens. So on each iteration, we take the current result and multiply it by the current value of I. Then we store that new value back into results. So let me show you how this works step by step for factorial iterative 5. So why we choose 5 is because here for the demonstration I put as 5. Okay, so we start with result equals to 1, and then when I equals to 1, the result will be 1 times 1 equals to 2, and then we're gonna return the value, and I will change into 2, and this will change into 1 multiplied by 2, and we will get 2. And this process will repeat until I equals to 5, which will get result of 24 times 5 equals to 120. So as you can see, with each pass through the loop, result will grow. Maybe if you can't see, I'm gonna insert another I here. I equals to 3, and we'll get result of 2 times 3 equals to 6, and it will repeat, and we're gonna see the value grows, the result grows. So by the time we finish the last number, the result holds our final condition equals to 120. So we will stop at I equals to 5 because when I equals to 6, that will be a false condition, so the execution will be stopped. So this line 5 return result is we return the result back to whoever called this function, so the iteration is complete. So if you notice something important here, is that throughout this entire process we only use one variable to store our result. So we just kept updating it over and over. So this is why iteration is memory efficient, because it doesn't need to keep track of intermediate states. Okay, now let's look at the recursive function. This looks much shorter, but it works very differently. So let me explain each line. So we're going to change the color of the pen. Okay. So again, we're gonna define a function that takes a parameter n, just like the iteration, this one. But this time, this function will call itself. And for line 2 and 3, this is what we call the base case, or from the slides, is commonly known as stopping condition, the condition that stops the function from calling itself. So this is the stopping condition. This is very critical because the key of recursive function must have a stopping condition, or it would call itself forever and cause a stack overflow error. Here we are saying if n equals to 0 or n equals to 1, don't do any more recursion, just return to 1. Why? Because mathematically 0 factorial equals to 1 and 1 factorial equals to 1. So this is our anchor, the point where the recursion stops. So for line 4 and 5, this is the recursive case. If n is greater than 1, we don't calculate the answer directly. Instead, we say that the factorial of n is n multiplied by the factorial of n minus 1. So if you notice here, the function is calling itself but with a smaller number because we minus 1. This is the essence of recursion, which breaking a big problem into a smaller version of the same problem. So now let's trace the factorial recursive 5. Since 5 is not 0 or 1, we go to the else block and we need to compute 5 times factorial recursive 4 because 5 minus 1. But we don't know factorial recursive 4 yet, so we pause and make a new call. So now we call factorial recursive 4. 4 is not 0 or 1, so we need 4 times factorial recursive, which is 3 because 4 minus 1. Again, we pause and call factorial recursive 3. So we were going to repeat the whole process until factorial recursive 1. Now we hit the stopping condition. Since n equals to 1, we return 1 immediately. So no more recursive calls are made. So when factorial recursive 1 returns 1 to factorial recursive 2, so that's when factorial recursive 2, can put here, factorial recursive 2 computes 2 times 1 equals to 2 and returns this one. We return to factorial recursive 3. And then recursive 3 will compute 3 times 2 equals to 6 and return 6 to recursive will return to factorial recursive 4. And then this process will repeat until factorial recursive 5, that will compute 5 times 24 equals to 120. Returns the final answer. So here we can see that the result is the same as iteration. Now that we understand both functions, let's compare them side by side. So as we can see, iterative function iterative we use for loop, but for recursion the function calls itself. And the termination, loop finish when I goes to n, but for recursive stopping condition, we're gonna apply stopping condition, which when n equals to 0 or n equals to 1. So the memory for iterative is single. It's because we only maintain one variable throughout the process. Single variable result. For recursive, we use multiple function call stack. One more thing to bear in our mind for recursion is that for recursion, it must be either decrease or increase. It cannot be recursive one or like n2 or n1. It must be minus or plus or even multiply or divide, as long as the number will decrease, the value will decrease or increase. Okay. So let's summarize what we have learned from this code example. Is that iteration uses loop to repeat operations. It is straightforward, memory efficient, and great for problems where you know exactly how many times you want to repeat. But for recursion, uses functions that call themselves. So it breaks problem into smaller versions of themselves, and it requires stopping condition and uses more memory because each call is stored on the call stack. Both approaches can solve the same problem, but the choice depends on the nature of the problem itself, the memory constraint, or the code readability. So some problems like traversing trees or solving the Tower of Hanoi is suitable for recursion, or are like either simple calculations or better with iteration. So that's all from me. Thank you for watching.